Hello and good morning. We want to do another exercise in integration and to show how one integral can sometimes be obtained from another. And this is suitable for years 17 and above. And the example I've used is to find the integral of dx over square root x squared plus 2x plus 2 and use that to find the similar integral x dx over square root x squared plus 2x plus 2. Right, so let's deal with the first integral, dx over square root x squared plus 2x plus 2, and write the radical as x plus 1 squared plus 1, and then make the substitution x plus 1 equals tan theta. So dx is sec squared theta d theta, and the integral transforms to the integral sec squared theta d theta over the square root tan squared theta plus 1, which the radical is sec squared theta, and when you square root it, just becomes sec theta. So we end up with sec squared theta over sec theta d theta, which is d theta over cos theta, and that's a standard integral, namely log to base c sec theta plus tan theta, and that will be equal to log to base c square root 1 plus tan squared theta, and then plus tan theta, and then reverting to the old variable, that will be 1 plus x plus square root x squared plus 2x plus 2. Now, for the second integral, that's x dx over square root x squared plus 2x plus 2. I've split that into two integrals. The first one being x plus 1 dx over the square root minus dx over the square root. Again, the second integral we've already worked out. So for the first integral, let's again, x plus 1 is tan theta, and the integral will transform to tan theta sec squared theta over sec theta d theta, which is the integral of sine theta sec squared theta d theta, and we're integrating that by parts. That's the first, which is sine theta, times the integral of the second, tan theta, minus the integral of the first differentiated, which is cos theta, times the second integrated, which is tan theta d theta. So that's sine theta tan theta minus the integral of sine theta d theta, and that's equal to sine theta tan theta plus cos theta, and then reverting to the old variable, which is quite easy because we've got x plus 1 equals tan theta. That simply comes down to the square root of x squared plus 2x plus 2. So the entire integral will be square root x squared plus 2x plus 2 minus log to base c 1 plus x square root x squared plus 2x plus 2. And you can go on in similar vein using similar methods to find the same kind of integral when the numerator is x squared, and then x cubed, and x to the fourth, x to the fifth, and so on and so on. And I hope that was helpful. Thanks very much for listening.